We're starting with the basics of series and parallel circuits today, and we're going to begin with the cell or the battery of the circuit. It supplies the chemical energy that then we transfer into electrical energy to make the circuit, to push those electrons through the circuit. What is electric current? It's exactly what it sounds like. It's a flow of electrons flowing through the wires and all of the parts of a circuit. Now, we say with conventional current that it goes from the positive end to the negative end. And something that I want y'all to notice here is that positive end of the battery is that longer end, whereas the negative end is the shorter end. Again, let me state that the conventional current goes from the positive end to the negative end. Which way do electrons actually go? Which way do the negative charges actually flow? They start at that negative end and go toward the positive end. This is an example of a simple circuit. Why is it a simple circuit? Because it has those qualities that we really have to have in one complete circuit. We have a cell or a battery that supplies voltage to the cell. Then we have wires that connect everything. We have a lamp or some sort of resistor, and then we have a switch to turn it off and on. You don't have to have a switch, but the idea is that all of the components have to be connected to make those electrons flow. If any of those is not then connected, then those electrons will not flow through there. So for example, when the switch is closed, just like when you go turn on and off a light switch, when you go turn on a light switch, that actually closes the circuit and then the lamp will light up. Whereas if we open the circuit back up, the lamp will not light up anymore. That really illustrates that if there's any breaks in the circuit, then the current will not flow through there, lamp won't light up. A couple of schematics or some drawings that you're going to see and you want to be able to recognize is first and foremost a cell. And keep in mind that longer end is the positive end, the shorter end is the negative end. That supplies your chemical energy to make the cell, to make the circuit happen. A lamp is represented here. That's just going to be a light bulb or any sort of thing you're using to change that chemical energy into electrical energy. And then a switch, see how that's open there? That's represented by a break in the circuit. We could just as easily bring that little line down there and then boop, the switch is on. And then lastly, wires are just going to be, they represent the metals that carry the electrons and supply the electrons to the circuit. Popping in these diagrams for y'all to be able to recognize. So if you ever see them in a schematic drawing, a cell, battery, they look quite similar. Notice that the battery technically is a couple of cells put together. Also notice that we put them positive to negative to positive to negative, right? Y'all have done that when you were little, when you try to hook batteries together and then all of a sudden you put them in wrong, it doesn't work. Boo, right? So you have to put those in a certain polarity. Other ones that you'll see really commonly are the lamp and the resistor. The resistor is that little squiggle, and that just represents anything that's going to utilize those electrons or that current in the circuit. Speaking of resistors, a resistor is any component in an electrical circuit that resists, we're using the word in the definition, the flow of the electrical current, aka light bulbs, a microwave, a telephone. Did I just say telephone? Oh my goodness, how old do I sound? A cell phone, how about that? A computer, anything that's going to be utilizing that electrical energy. Another thing that I want to point out, guys, is there's not a catch-all when we represent light bulbs. It's so annoying. But in general, we have a resistor, that's that squiggle. And remember, that could be anything that hinders the current from flowing through the circuit. These, I wanted you to be able to recognize and see that they're all represented